So guys, it's anabology, and today I'm doing an audio overview of the honey diet and the history of the diet. So the honey diet, I think the shortest explanation of this that uses the technical words, so don't worry if you don't understand exactly what this means yet, is that the overfeeding of liver targeting carbohydrates or fats in a protein deficient state overinduces FGF21, increasing whole body energy expenditure more than food intake, causing weight loss. So a shorter, maybe more clear version of this explanation or summary is that if the liver sees more calories than the rest of the body in a state where it's primed to control the rest of the body's energy expenditure, when it doesn't see any protein, it desperately tries to make the rest of the body burn off all of the calories that it sees, and sometimes more. So why does this happen? Why does the liver sometimes just freak out and burn calories and try to make the rest of the body burn all of these calories and increase the metabolic rate of everywhere? Well, I think that this goes back to evolution, where there were these states previously, there were these animals that ate basically only fruits or only fats in these really weird foods. Maybe the animals only got coconuts, or maybe the animals only got some berries around them, or maybe they only got apples. And if the animals ate, say, 4,000, 5,000, 6,000 calories of these foods, then they would get fatty liver if their metabolic rate didn't increase, right? So say I today, with no metabolic rate increase, I burn 2,000 calories. Well, then I ate 6,000 calories, and what happens? Well, what happens is the calories go into my body, they go into my bloodstream, they go into my liver. And if there are these calories that get into my cells that I cannot burn right now, well, they still try to get burned. And that begins to just release these electrons. Instead of going to the proteins that help me burn the calories, it just goes to oxygen instead, which causes these reactive oxygen species to get made, and then it causes damage everywhere. Another thing that can happen is that the calories can be kept in blood. And that's also a bad thing, because if the calories are kept in blood, if they're glucose, they glycate the extracellular matrix. They glycate all of your blood vessels. They start to cook everything, basically. Whenever you see in an oven, you see all of your food turning brown, well, that's like the Maillard reaction. There's kind of glucose or sugars reacting with amino acids, which is basically glycation, and then the material properties of the food changes, the color changes, and gets cooked, right? So basically your blood vessels can get cooked when there's too much glucose around. What also can make the blood vessels get cooked isn't just glucose, it's also the dietary fats that are reactive. So seed oils, omega-3s, these can also react with proteins and modify the extracellular matrix, basically cooking it. So basically what this is saying is that what you want is you want your blood not to be full of calories, because then it destroys your blood vessels and extracellular matrix. You also don't want your cells to be full of calories more than they can handle, because then you create this damage inside of your cell. So you basically need your amount of calories to be the same as the amount of calories that you burn, right? The amount of calories you eat needs to be the same as the amount of calories that you burn. And if you have a food that, to get the amount of protein that you need to survive, to build muscle, to turn over immune cells, to just do all the functions that you need to do with protein, with nitrogen, with sulfur, with the things that you can only get in protein. If to get the amount of protein that you need required you to eat 6,000 calories when you can only burn 2,000, well, then you would just die, right? So the body, the liver specifically, has figured out how to deal with this. When it sees more calories than it could otherwise burn in a protein deficient setting, it increases its metabolic rate, and tries to do that with the rest of the body too, because the liver sees the calories first and it can respond quickly. So then what the honey diet does is it tries to hack this, right? It tries to make the sensing organ for calories in a protein deficient state react too much and then burn too many calories. So there are a couple different macros that can do this. One of them is fructose, and then the other one is MCT, or kind of subsets of macros, right? Carbs and fat can both do this. But fructose and MCT, they both go directly to the liver. They target the liver first, and the liver sees more calories than the rest of the body because the export mechanisms of these kind of macros are somewhat rate limited. And when the liver sees a ton of fructose or a ton of MCT, which fructose is half of sucrose, and MCT is part of coconut oil and some other fats, cream, for example, then the liver produces too much of this factor called FGF21, which increases the metabolic rate of the entire body, and it burns so many calories, even more calories than you've eaten. And then that lowers weight. Right, so just in summary, again, if the liver sees more calories than the rest of the body in a protein deficient state, it desperately tries to make the whole body burn more calories. Maybe to protect the liver, to get enough protein without becoming unhealthy, but this is what happens. So theoretically, you can induce this factor. You can induce FGF21, the factor that the liver releases when there's too many calories with no protein, and you can not lose weight. And the way that you would do that is you would do it with glucose and with stearic acid. So the longer chain fats that distribute more evenly across the body. They cause a little bit of insulin resistance, so that it floats in blood for longer. And then glucose, which is nicely distributed across the entire body and doesn't specifically target the liver. The liver sees the same amount of calories as the rest of the body, or around the same. So even if you induce FGF21, it's not induced strongly enough to burn more calories than you ate. Right, so that's why the sucrose or the fructose of the MCT is specifically needed. So just onto the formulation of the diet, right? So gotten through the background and the evolutionary argument behind it, and the actual diet, the way it was formulated is, the beginning of the day, you eat sugar, and as much sugar as you can, all the way up until 3 p.m. or around kind of middle late day, and then after that, you fast for a few hours, and then you eat a large protein dinner with some fat as well. And then overnight, you use that protein, you use that fat, you burn it all. And then by the morning, you're kind of reset metabolically and you're ready to eat sugar again. So protein totally stops this FGF21 response. You can eat unlimited fructose, and if you have enough protein, your liver is not going to increase your metabolic rate. So you have to separate them temporally. And then this begs the question, why not just do no protein or very low protein? Well, the reason why I formulated it where you still get plenty of protein is that eating a very low protein diet in humans increases all-cause mortality. So it makes your chance of dying much higher. And this was studied in chronic kidney disease patients where if they ate low protein, there was less stress on their kidneys. So their kidney disease risk got better. But these chronic kidney disease patients put on a low protein diet actually died more. They had a higher all-cause mortality than the kidney disease patients who weren't put on a low protein diet, despite it helping their kidney disease. So that basically tells you that in humans, doing low protein is just not great. Right? In the best case scenario where you're helping these patients with chronic kidney disease, where there's a direct mechanism where low protein helps, low protein made them die more, which is sad. So the way I formulated this diet is there's a period in the day where you can abuse this low protein mechanism, where you can eat more, way less, your metabolism can speed up, but you can still get all of your protein, you just get it at dinner. And this is almost analogous to just a 1 meal a day diet, kind of intermittent fasting. So I don't think it's too dangerous to have this period of low protein, because it's almost like intermittent fasting. Half the day your body is mostly exposed to fat in intermittent fasting from your own body fat, and then at dinner you refeed in all the protein. And then fasting can also induce FGF21. So basically intermittent fasting is a keto version of the honey diet, where for most of the day, you're only eating fat because you're eating fat from your own body fat stores. And then you eat a big protein dinner, and then that inhibits your body from delivering fat to your cells as calories, because now you become kind of insulin resistant for a little bit from the protein. Your body stops breaking down all of its own fat because it sees fat externally. And you get into this program where, where now you inhibited FGF21. So anyway, the honey diet was built in this way because of the different timings of how long it takes to burn off different macros. So if you wear a CGM and you're in this protein deficient state, a continuous glucose monitor, you can see that your blood glucose spikes once you eat glucose, of course, and then over the next few hours, it goes back down to a baseline. So it only takes like a few hours for you to burn through basically any amount of sugar that you eat on this diet whenever you're in a protein deficient state. However, if you eat protein and fat or just any long chain fats, so like the stearic acid, like the tallow, the cocoa butter that I was talking about, these stay elevated in your blood, and same with kind of a really high glucose food, stay elevated in your blood for much longer than just a short pulse of sucrose or MCTs. So what that means is that if I decided to formulate this diet in reverse, where I put the protein meal at the beginning of the day and then a high fat meal in the beginning of the day, there would be no period in your entire day, waking day, where you could eat any sugar because the entire time you would be inhibiting FGF21 from the still circulating amino acids. So essentially, you need to put the high protein meal at dinner so then you can sleep through all of it when you're naturally going to be fasting, and then you can eat sugar through the rest of the day. So again, just to reiterate, the diet is high sugar throughout the entire day, so you can burn it off, and then once you burn it off, then you can have a high protein meal with fat to keep your hormones up, to not have zero fat so you can't make any hormones. And then you sleep through the time that takes you to burn all of that off. And that's basically it, right? Just separate the sugar and fat temporally, and you have to put the sugar before the fat. But you could also replace the sugar with MCTs. Like MCT mayo would be a good example. You could just literally eat lettuce with MCT oil and maybe an egg yolk in there wouldn't really ruin it. And you should be able to do a keto version of the honey diet. So, and I have this protocol on my website, longestlevers.com, if you want to go there for like the more detailed, saved in text version of this diet. So, how did I get to this diet? So there were a few data points that I looked at originally before I formulated this diet that really made me encouraged that sugar wasn't going to be the worst thing in the world for obesity, despite me doing carnivore and similar like lower sugar diets before. So the first one I want to talk about was this 1983 study called Effects of Sucrose, Caffeine, and Cola Beverages on Obesity, Cold Resistance, and Adipose Tissue Cellularity. And I can't produce this author's name, Bukowiczki et al. Don't know how to say his name, 1983. Basically in the study, there were mice who drank Coke instead of water, and they had higher energy expenditure and cold resistance. So they ate more and they weighed less, and they were resistant to cold, they were warm, and they ate 50% more calories with like no weight gain. So in the study, they separated the effects. They basically like found these mice that can drink a bunch of Coke and somehow did not gain weight. And they also gave them just sucrose or just caffeine instead to see what effects caused what. And they found that they were able to replicate basically all of the effects with just sucrose. But the caffeine helped prevent white adipose tissue cells, adipocytes, from proliferating, right? So most of the effects actually came from just the sugar and not the caffeine, but the caffeine had like a little bit of a helping hand, right? So like, what does this tell us? This tells us that if you drink a bunch of sugar, it's probably not going to make you fat. Maybe in a different context it can, but caffeine can help a little bit too. So I was like, that's cool. They're eating more and weighing less. It's like a pretty remarkable result that goes against all of these calories in, calories out folk who think that the only way that you can alter your weight is by eating less or exercising more, which would suck. So then there was a 2010 study that kind of replicated this unknowingly. And the title of the study is called Chronic Consumption of Fructose-Rich Soft Drinks Alters Tissue Lipids of Rats. So like just by the title of the study, they are saying that fructose containing soft drinks, like high fructose corn syrup soft drinks, like Coke, Pepsi, whatever, they alter tissue lipids of rats. What that means is that these rats, they were saying, they are predicting that these rats have worse cardiometabolic outcomes. That's usually what authors mean when they're studying tissue lipids. They're saying cardiometabolic outcomes are worse if, say, your blood lipids are higher, or if your liver lipids are higher, like if you have fats deposited in your liver, which are these tissue lipids in this case, they're going to have worse liver outcomes, is what they're saying. So they're basically saying that these fructose-rich soft drinks are bad for you. But then if you look into the study, the rats that drank Coke, so they drank Coke instead of water, they drank 4 times the calories and ate 4 times the calories as the other mice. So if you're eating 2,000 calories a day as an adult male, this would be drinking 8,000 calories in a day. And they had no weight gain at all. And they just had slightly higher triglycerides. Like the amount of triglycerides that were raised and the amount of liver fat that they gained would not influence mortality that much. It just like altered it a little bit. But they ate 4 times the calories and didn't gain any weight. That's like an insane result. Like how are they just like had like maybe one line in the study that reported on this after they have the graph. It's just, this is like the biggest finding in their study, and they just are so anti-sugar that they had to make the title a negative thing, not, oh, we discovered that you can drink 4 times the calories and not gain weight. So it's kind of insane. And I was like, how does that work, right? So what really allowed me to figure out how this works, and I think I'm correct now, over these more and more studies being published and everybody trying this diet, there was a lambing lab study called, where they found that you can restrict this one amino acid, isoleucine, which is a component of protein. It's a building block of protein that's needed for quite a lot of proteins to be made in your cells. And they found that if you restrict this one essential amino acid, isoleucine, that the mouse lifespan increases by over 30%. And that these mice that had the longer lifespan ate more and they weighed less. And they found that this factor, or this metabolic rate increase and lifespan extension, works through this factor called FGF21. So FGF21, again, is this factor that is induced by the liver when the liver sees calories in a protein-restricted setting, and they just replicated this through restricting the one amino acid, isoleucine. So again, 8 more, weighed less, live longer, kind of like this theme, and it works through FGF21. So then there was like other studies that have replicated this, but directly with FGF21, where they genetically modify the mice to express more FGF21, and they eat more, they weigh less, they live longer. Like for example, a study called the starvation hormone, FGF21 extends lifespan in mice. And they call it the starvation hormone here, even though it has many different roles, like not just starvation, because when you fast, it gets induced, and fasting is a low protein, high fat state. Which before, as I've talked about, if you give the liver calories, in this case from your body fat, without any protein, you induce FGF21. So then there have also been studies where even in humans, they find that protein deficient overfeeding of fat or carbohydrates induces FGF21 strongly. So you can take a human, and an example of this is a paper where they studied the thrifty metabolic phenotype. So there's this idea that if you have metabolic trauma as like a child, or your mother has metabolic trauma, that you will become more fat even on a normal diet, because there's this like long-lasting thrifty phenotype that you get that makes you fatter once your metabolism slows down. So there's this paper called FGF21 is a hormonal mediator of the human thrifty metabolic phenotype. In this study, they found that when they overfed humans with carbohydrate or fat, FGF21 was strongly induced. So this is like a good encouragement that overfeeding of these macros can induce this factor that in these mice extended lifespan made them eat more and weigh less. However, they found that some humans had a blunted FGF21 response, and that was associated with just overall higher obesity rates and this like thrifty metabolic phenotype, where the metabolic trauma that they had when they were young causes them to be fatter for longer. So, it's a little discouraging for people who are already obese, but if you're otherwise healthy, this diet seems like it'll work pretty well. And FGF21 was still induced, just less strongly. So the diet could work if you are already obese, where you try to make the liver induce FGF21 too strongly and make the rest of the body burn more calories. It could work. It just might work a little bit more slowly, and you might have to restrict calories a little bit more, is the idea here. But anyway, the unifying theme of all of these different studies is that eating sugar in mice seemed to be able to raise the metabolic rate an insane amount. And I found through other studies that restricting protein caused this factor called FGF21 to be induced, and overeating sugar also induces this factor, but specifically in protein deficient settings. And overall, this tells you that if you ate a ton of sugar, like a pound of sugar plus a day, and you restricted protein, that you would lose fat. And so I tried that. I tried that with honey. I ate a pound of honey a day, a half pound of dates, and then I would do that in the first part of the day and then burn off all the sugar at the gym or just, idly. And then by dinner, I would eat a pound of beef, a pound of vegetables, a pound of mushrooms, some soup, right? Just like big dinner, but most of the macros are going to be from the beef fat and protein. And I lost, while eating more calories than before, about 1,000 calories more than before, I lost 10 pounds over a month and a half, and it worked pretty well. And now people have tried this. Alex Hardy is a good example where he did the honey diet and he lost maybe like 15 pounds by this point and did DEXA scans and gained lean mass during the time on the honey diet. So it seems to be maybe even better than just calorie restriction or Ozempic or something in terms of lean mass outcomes, where if you just restrict calories overall, you do lose quite a bit of lean mass while you lose weight. So yeah, anyway, all of these studies led to the idea that sugar should increase FGF21 in humans, specifically in humans, and increase energy expenditure, lowering body weight, and it seems to work. And this has been confirmed somewhat by studies recently that have come after the honey diet started. This started about a year and a half ago. Right now it's May 4th in 2025, and I started this probably in about November of 2024, or 2023 actually, sorry, years are hard. And but recently in Nature Metabolism, there was a study that was published, and it was published on March 6, 2025, so over a year after the honey diet started. So they were probably doing this during or after the honey diet started. It's called Dietary Protein Restriction Elevates FGF21 Levels and Energy Requirements to Maintain Body Weight in Lean Men. So basically what happened is in this study, they restricted protein in humans, and I believe it was specifically male humans, lean men, and their energy expenditure increased. And they actually did in the study what I would call a weight clamp. So in biology, if you want one variable to stay consistent, you call it a clamp, and you clamp the thing, right? So in cells, there's a thing called a patch clamp, where you can clamp either voltage or current. You can force the voltage of a cell to remain the same thing, and you call it a voltage clamp. And then you can measure the current as the voltage is the same, and then determine resistance, for example, right? So in this study, what they did is they clamped weight, and a colleague reached out to the author, and he said that as the energy expenditure increased, to maintain the same weight, they just gave them more food, right? So they didn't look at weight loss. They maintained the body weight forcefully of these men in the study, but they found that when they restricted protein in men, FGF21 increases, and it increased their energy requirements. So in, calories out, they increased calories out by a simple dietary change. So some other studies that are interesting in context of this that I found when kind of coming up with the diet, there was another study that's pretty cool where they, it's called, in 2022, Carbonated Beverages Affect Levels of Androgen Receptor and Testosterone Secretion in Mice. So these were Chinese researchers, and they found that giving mice basically Pepsi or Coca-Cola, either one, and Pepsi actually worked a little bit better. The testosterone in mice basically doubled, or just much higher, and the androgen receptor almost nearly doubled as well in these mice. So these testosterone's raised a ton, and it seemed to work pretty dang well in these mice. And I think that they saw some testicular hypertrophy, and maybe they thought the histology of the testes looked a little bit worse, and they were saying that it was a negative thing because of maybe lower fertility. But this is there have actually been studies showing that eating sugar increases attractiveness. So if attractiveness is a proxy for fertility, then I would contest their histological results there in humans. Another thing that I try and do is I try to generally make my decisions based on what will make me live longer. I'm in the longevity field. I believe in longevity, so I want to live longer. There was one study, it was called Effects of Lifelong Sucrose Consumption at Human Relevant Levels of Food Intake and Body Composition of C57 Black 6 mice. This is like a 2022 study where it was like kind of underpowered, but they basically gave mice the same diet, either with high or low sugar, and they replaced sugar with starch. And the mice that had 25% of their calories as sugar versus 10% of their calories as sugar lived a bit longer, and there was actually a pretty large gap in the lifespan difference, where it was like 10 weeks increase, maybe like median lifespan, but it was kind of underpowered. And 10 weeks in these mice is like 70 days, and mice usually live about they're supposed to live about like 900 days. In this study, they lived more like 700 days. So it's like not a great study. But in the only animal data available, the lifespan increased by like maybe 10% when they had a higher sugar diet. So when you look at the epidemiology of sugar and try to look at what in humans the lifespan effects are, there are basically a few different categories of sugar. There's fruit, there is candy, and then there is like sugar sweetened beverages. So the people who eat fruit live longer, the people who eat candy live longer, and the people who eat sugar sweetened beverages like Cokes or sodas live a shorter amount of time. And the hazard ratios, so it's basically like the modifier on risk of an event happening, in this case death, they're always about 0.8 to 1.2. And what that means is that there's like a 20% increased risk or 20% decreased risk of dying, which corresponds to not very long, like a year plus or minus living longer or shorter. So in these cases, my interpretation is that sugar is pretty much neutral for lifespan, because like some sugar sources seem better, some seem worse, and all of these could just be explained by healthy or unhealthy user bias. And what that means is that the people who are drinking sodas are probably also eating processed foods and other just terrible things, or also Snap provides soda currently, and I think this is being changed. So it'll be interesting to see how these studies change, but food stamps provide soda to a lot of people, and poor people live shorter lives. So the effects that you see here where the sodas are bad, it might just be an effect of like socioeconomic factors rather than a true cause and effect relationship. Whereas the people who eat fruits living a longer time might also just be healthy user bias, because generally healthier people tend to eat fruits, or wealthier people as well. So it's like the epidemiology, where you look at just the associations, it doesn't look good in terms of the quality of data. And there's like no real conclusions that can be taken from that. And also the animal lifespan studies, which you could get some more insight from to see if the actual interventions increase or decrease lifespan, they are slightly positive for sugar, but generally underpowered. So anyway, like the overall thought there is that sugar is probably not bad for lifespan, might not be good for lifespan, but it's not going to be a big modifier of risk. When you look at the bigger modifiers of risk, there's things like cigarettes, which like triple your risk of dying. There's things like sauna, which cuts your risk of dying in half. There's things like stretching, which for women also cuts your risk of dying in half. These things are like a much, much bigger effect, and I'm like much more confident that there is a causal relationship there, rather than just like this slight modifier that you get by being wealthier or being around healthy people. So sugar, again, from epidemiology, doesn't really matter that much. So I was comfortable in doing this diet where I was eating like a shit ton of sugar. And my blood biomarkers before and after the diet didn't get much worse. Basically, my DHEA went up, my cortisol went down, my estrogen went down, my testosterone stayed around the same, my free testosterone went up, my insulin stayed around the same, my hemoglobin A1C was 5.1, which is consistent with being non-diabetic. My average glucose was around 100, between 100 and 105, depending on the day. And that is also consistent with being non-diabetic. I maintained glucose tolerance. My body temperatures were consistently 98.6 in the middle of the day. By every discernible metric, I became healthier after eating this diet. And this is what the data suggested would happen, assuming that the blood work is still, in the present day, a good proxy of your risk of mortality as life insurance companies think it is. So that should give probably enough context for the honey diet, the history, the studies. I would like to move on to just some kind of new thoughts that I've had since then, and maybe some FAQs here. So first of all, just how I think about diet and the axes of diet. So one of the first things that I think about is there are these two axes that I see in diet. One of them is satiety, and then the other one is hunger. And basically the thought here is that the foods that induce hunger need to be able to increase your metabolic rate. And the foods that induce satiety don't have to increase your metabolic rate, but they shouldn't, make you hungry. They should, if they don't increase your metabolic rate, they should be really, really satiating. So on the two sides of this, the satiety inducing foods, these foods are like beef tallow, cocoa butter, protein, starch. These are very clean foods, long chain saturated fats. Glucose can just be kept in your blood, and insulin resistance can properly keep it out of your cells. Protein can also cause some sort of insulin resistance and keep sugar in your blood. All of these macros together cause massive satiety and don't seem to decrease your metabolic rate and seem like they would go together. And if you're eating a mixed macro kind of diet, these would be the best ones to pair together if you want to do this and just not eat between meals. So that's starch, potatoes, rice, tallow, beef, chocolate, but with low sugar. I would do low sugar chocolate, cocoa butter, and other foods are kind of harder. I would do lower calorie, higher fiber foods. So you could do vegetables, so bone broth, asparagus, broccoli, all of this cooked in beef tallow. Just the lower calorie food, seaweed around your rice. You could do sushis, but I would prefer sushi without fish because the omega-3s can mess things up. Lean fish cooked in beef tallow, all of these things I think could be part of a good satiating diet. And this is also the mechanism that things like Ozempic abuses, because the leptin is this long-term or long-distance kind of signaling mechanism, like leptin ghrelin for satiety or hunger. And they basically just try to make you eat less. So I think all of those go together. They don't modify the calories out very much from what I've seen. But then there's another alternative where if you want to eat more, just eat all day, and you want to be hungry, but also be able to satisfy your hunger, there's another way. And the other way is basically the honey diet, right? Where you eat a ton of a macro that increases your metabolic rate more than the calories that you eat, right? So what this is basically fructose, MCT, and those are the best ones, right? And then there's also shorter chain fats. So there's myristic acid, lauric acid, not really MCTs, but still kind of a little bit better. C8 would be better than C10 in the MCTs. And there's sucrose instead of fructose, which is 1-to-1 glucose to fructose. You could do fructose with a little bit of starch as well. So you could put agave onto rice, and that would mimic almost sucrose. But as you get farther and farther away from this hunger-inducing, liver-targeting, FGF21-inducing regime where you have no protein, you have high fructose, high MCT, then you get into this swampland where you have a macro that doesn't really increase your metabolic rate, but it also doesn't really make you satiated. So then you end up just getting fat, right? So you want to just stay pretty far on either side of the spectrum. You either want something that makes you really, really just in your face satiety, or really, really hungry, but raises your metabolic rate because it hits the liver. And those are the two dietary regimes that can work. And then the next level to this is, how do you temporally put these together? And the answer is, you just put the hunger-inducing ones before the satiety-inducing ones. So you start the day with something that makes you hungry, and you burn off all these calories really fast, and you start the day with something that increases your metabolic rate. And then once you eat the satiety-inducing foods, then the rest of the day you just cruise on that, and you don't eat between meals. Or you just eat many very small meals, right? But that's when calories start to matter. But it's not a big deal because it makes you satiated. So then this expands the honey diet to be many different things, right? Like anything that increases your metabolic rate and makes you hungrier can be put in the first part of the day for any amount of time. And anything that makes you satiated and doesn't increase your metabolic rate can be put at the end of the day, also for any amount of time, but then calories matter more after that point. And then also you could have entire days where you do one or the other, right? You could do a Coke fast for a week. You could do MCTs and fructose only for a week, but I would recommend adding egg yolks if you did that to be able to get the egg lecithin to export fats from the liver. Or you could just do mixed macro meals all the time forever and just be happy on that, and then try not to snack too much. So with like the clean foods, that's like where I think like the main effects come from. And then there's a few other effects, right? The next notable one is gut absorption and motility of the gut. So one thing that can mess up the honey diet is mangoes, unfortunately, because like all my brain wants is mangoes, and mangoes are so tasty. Certain macros like mangoes, certain foods like mangoes, rather, they can induce constipation. So if a food hangs out in your gut for too long, you can have overgrowth of the gut bacteria. You can have other foods that just get stuck in there and they absorb for way too long. You don't excrete anything. You get all these like second order negative effects that cause you to gain weight, even if the macros are correct, right? So you just really mess yourself up if you have anything that induces constipation when you eat a lot of it. You can eat like a little bit of mangoes. It's not going to be a big deal. But if you have a lot of mangoes, it can stop up the gut. And there's like many other foods that can really stop up the gut, additives, etc. And one of the things that helps with the honey diet is that when you eat like this, you have many bowel movements all the time, all day. And things like coffee can help with this as well. I think Coke for many people also somehow clears out the gut. I have no idea why, but it really does. So if your gut is really slow and not moving, you're just going to gain weight. This is like pretty well known. Even if you have the correct macro ratios. So then another aspect of this is uncoupling. Certain macros can cause your mitochondria to uncouple, and they will, instead of producing energy, they will just produce heat and burn through things faster. Cold exposure, maybe ultraviolet light, these things can cause some increase in metabolic rate, maybe through uncoupling as well. And this is like another axis that you can like pull the lever of and see what it does. I would caution against uncoupling agents. So like DNP is a weight loss drug that people use. And what it basically is a metabolic poison. Like you just stop energy production, so then you produce heat instead only to like the mitochondria adapt to try and like push through as much flux through the mitochondria as they possibly can. And they produce a ton of heat because they're poisoned, right? So uncoupling is bad whenever uncoupling happens before you produce enough energy. You can induce a very low energy state by uncoupling with seed oils, for example, because you just like compromise the integrity of the entire mitochondrial membrane and cause like a leak of protons in the conventional models. And then you don't produce enough energy despite being uncoupled. So then you get these things where you get cancer, which is like this chronic low energy state that somehow loses any ability to communicate with the external environment like reversibly and know what cell type it's supposed to be, and then it moves around and It's depolarized electrically. You get muscle cramps. You get heart failure. You get all these terrible things when you uncouple enough. But that's when you force uncoupling, when you have a lack of energy. However, uncoupling with thyroid hormones, to a degree, too much is bad still, but if you uncouple naturally with like cold exposure or with having a lot of calories, maybe through FGF21, then it's not too bad a thing because you've already produced enough energy and now you're just kind of going through these extra calories and producing heat. So that's like another axis that can confound some different results, right? Because there are some swamp diets where you're just eating the worst macro ratios possible, but the macros like the seed oils can uncouple you and you don't gain weight, but you get all these other terrible effects like inflammation, like disease, whatever. And then another axis to this is toxins, right? No matter what diet you eat, if you're just like metabolically poisoned with, say, dioxins around you, all these terrible industrial toxins that slow your metabolic rate, just mess up your metabolism, there's like not that much you can do. And you have to do these extreme diets like the honey diet. You can't eat like a normal diet anymore, which just sucks. And the best way to get rid of these is one, lose weight because a lot of them are lipophilic. So do anything you can to get rid of the fats and get rid of the exposure of the toxin. And two, do sauna every single day. Sauna is like the most consistently detoxifying intervention that I've seen in the literature. Basically, anybody that gets industrial exposure to like some toxin, if they do sauna, it usually gets rid of it in like their by blood levels. Those are the axes that I think about diet. And then once you dial kind of those in, like you make the decision on the satiety versus hunger axis, you think about uncoupling like a little bit where you don't want to take uncoupling agents, but things like cold exposure, maybe UV light, FGF21, like these things can help with increasing your metabolic flux. If you dial in your gut absorption and motility, where you don't have things that stop up your gut and you reduce your exposure to toxins or you use sauna to get rid of toxins, you basically have solved diet. There's like not much more than that to do, I feel like, and you will be skinny. So satiety, hunger, gut, motility, absorption, uncoupling, toxins. Those are the 5. So then some FAQs. I'm just going to go through a few. I think what would be great is if after this, I'll post this and I'll ask for more questions that I can answer in a future audio monologue here, soliloquy. After this, I'll ask for more questions, but I'll just go through a few quick ones here. So number 1, can I just do fruits on the honey diet? No honey. Yes and no. If you want to maintain weight, I think doing fruits only is great. It's like pretty easy for people to do. But I will say that protein adds up in fruits, so you may have to limit calories a little bit more because the FGF21 response isn't as strong as if you do pure honey. 2, can I drink alcohol? Yeah, you can. It's actually better in the sugar phase. So if you do an entire day of no protein, no fat, just sugar, that would be the best day for ethanol. It also induces FGF21 very strongly. But don't do too much, because if you do like basically no protein, no fat, a lot of alcohol, you will become probably much drunker, much faster, and you might black out. Not that great, but you can. It works on the diet. Can I do candy and sodas? Yeah, it's like totally fine to do on the sugar phase of the diet. It can also help you if you do that, because then you don't have any protein in those foods to worry about. But just like be careful about the macros in candy, because sometimes candy can have like palm oil or other things, and you'll be in a mixed macro scenario. What if I work out in the morning? Yeah, so basically I think you can totally work out in the morning and everything will be fine. What I usually recommend is just like do some coconut water or juice before. Juice has like a tiny bit of protein in it, so just use that. Use juice during your workout. Eat a bunch of fruit and juice after the workout to get like a little bit of protein in there, and then eat a big protein dinner later in the day. And the actual muscle growth, like past the initial swelling that you get of the muscle, happens over weeks. So the dinner protein will work just fine. And you can know that if you're too sore, maybe you aren't recovering fast enough, and then maybe add a little bit of protein after your workout in the morning and then see if it helps your recovery. But if you're not too sore, then everything is fine. Will my gut adapt to this diet? So a lot of people, when they start, they have like diarrhea, their gut, you have too many bowel movements, and the answer is yes. Generally, people after the first couple days, their gut kind of starts to make solid bowel movements again, and it does adapt. So there's like a couple day transition period once you start adding a lot more sugar into your diet. But I think it gets easier over time. Like you kind of equilibrate to a diet where you say do maybe your higher starch, higher protein day, and then you do the sugar day, and then there's like no adaptation period. It seems like you reach some new equilibrium where you don't need to go through that first like longer diarrhea period for the subsequent times where you go on and off the diet. Can I do zero protein for some time to accelerate weight loss? Yeah, there was a study in mice where the mice were given no protein for like a week, and the mice that had only like 1% protein in their diet versus like 2% versus like 5%, whatever. These mice that had zero protein, they lost like most of their body fat and didn't really lose much muscle at all. And the mice that had like 1% protein or 2% protein, like the ones with, small, like low protein, but still some protein, actually lost less fat and had around the same amount of lean mass at the end. So it looks like, based on the animal data, it's still speculative, but you could do a zero protein diet and kind of like a Coke fast, or even a juice cleanse would put you into the bins where you're not getting the full effect, and lose like a ton of body fat really fast while eating. So I think it's possible. It would basically be like Coke and candy and honey and maybe MCT mayo. I don't know. It's pretty hard to do zero protein if you're eating real foods. But I think it's possible, right? A cotton candy diet. And then are blood sugar spikes bad? So what I think about here is, why do you think blood sugar spikes are bad? The two reasons why people come to this is, one reason is that blood sugar spikes will increase glycation. So glycation, again, is like the cooking of your extracellular matrix. Glucose reacts with all of these things, and all these proteins in your blood walls, all your arterial walls, or the interstitial fluid around your tissues, and it can cause it to stiffen over time, which is not great. But you can measure this, right? So hemoglobin A1C is basically the glycation over a month that your hemoglobin sees, because it turns over time, and you get to see your kind of last month of glycation because it gets glycated as well. And if your hemoglobin A1C is in a range where you don't look diabetic, you don't look like you have a terrible, super high glycation all the time, well then obviously you're not glycating everything too much, right? You're glycating your hemoglobin A1C just as much as anybody who's healthy, right? So just like look for hemoglobin A1C that's between maybe 5 and 5.5. And if it's in that range, like you're totally fine and your blood sugar spikes aren't too bad. Another metric that I want to pay attention to here is your average glucose to hemoglobin A1C ratio. So your average glucose should be around like 100 over the day if you wear a continuous glucose monitor, and your hemoglobin A1C should be around 5.1 if you have an average glucose of 100. But if you have a hemoglobin A1C of like 6 and you have an average glucose of 100, well, that means that for some reason your glucose is glycating your hemoglobin even more than you would expect based on your blood glucose. So what that means most likely is that you are somehow metabolically inhibited. So carbon dioxide is what they call like a byproduct of metabolism, but it's also just a product of metabolism. It's a very good thing. It protects the parts of hemoglobin in the extracellular matrix that get glycated from being glycated by glucose. It like protects everything from being cooked. And if your CO2 is too low, then this ratio can get all out of whack. You can have a hemoglobin A1C that's like way higher than you would expect based on your average glucose. And this is like the key metric, I think, that tells you whether or not you're metabolizing everything correctly, right? So it would be worth it, I think, to test this over time to see if your hemoglobin A1C matches the average glucose. And you can use ChatGPT or Grok to get the exact correspondence between hemoglobin A1C and average glucose and see if you're above or below that. And then if you are above or below that, if you are much above where your average glucose predicts a lower hemoglobin A1C than you actually have, then you probably don't want to increase your calories to the levels that I'm saying on the honey diet. You don't want to eat like unlimited calories because you're metabolically inhibited and bad things are going to happen. You're going to glycate everything too much. Your blood sugar spikes are going to be bad. And just generally you have mitochondrial dysfunction and you don't want to stroke the fire. You want to do maybe a more conservative calorie restricted diet until you fix these other problems that are in your way. So anyway, that was a big rant. I'm going to try and do more of these audio long form rants over time. See if it's a good format that people like, because it's easier for me to sit down and just do this rather than have to write threads to get this information out to you guys. So yeah, excited to keep doing this, and let me know if you like it. Let me know if you hate it. Criticize me. Happy to take any criticism. But this is my first one, so hopefully I'll look back on this in a while and be like, wow, I'm so much better at speaking now. Anyway, signing off.